Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and very good morning to all of you. Okay, until now we have 16 of you. Afiq Haziq, okay, Alia Hasrina, Amirah Fatini, Azharin, Dahlia, Aisyah, Ismail, Muhammad Adam, Muhammad Afiq, Muhammad Azim, Muhammad Mirza, Muhammad Zaf, Zafar, Nur Al-Safir, InsyaAllah. 16 only. Okay, so I cannot wait for your friends. So we start our discussion today. Okay. Okay, can you see my sharing page? Okay. Seventeen. Okay, today, so we will proceed our discussion about subtopic 7.2, potential energy and kinetic energy. So yesterday we have discussed about 7.1, work, energy and power. So I hope that you can understand the basic concept relating work, energy and power, how they relate to each other. So that knowledge, that basic knowledge will be used in this second subtopic, potential energy and kinetic energy. So as we have learned, as you have learned before about the definition of energy, so I want you to remember again. Okay, look back. What is the definition of energy? What is the definition of energy? Energy is an ability to, energy is ability to do work. Okay, so this is the definition for energy. So means that in order for us to do a work, so we need energy. We need energy. So when work is done, so when work is done, so the principle here is when work is done means that energy is used. Okay, so energy is used. So the background for this one is value for work that is in joule is same with the value of energy use. So this is the background of this concept. Yeah? So when work is done, means that the energy is being used and the value for that energy is same as the work done. Yeah? As you know that work, the unit is joule, and the unit for energy is also in joule. Yeah, J. Yeah, so same unit. Yeah, but different quantity. Yeah, so work, as you have learned. Yeah, so definition of work is what? So you must remember again, work is force times displacement or distance taken place by the movement of an object. Yeah, displacement. Yeah. So this is the definition of work. Yeah. And then in order for work to function, so we require energy. So now we will learn about certain type of energy. Yeah. So energy, we have various type of energy depend on the situation. Yeah. So we have various type of energy depend on the situation. Now we will learn about two type of energy, that is potential energy, yeah, and kinetic energy. Okay, so two type of energy. Potential energy, in VM we say it as a tenaga keupayaan. Yeah, tenaga energy keupayaan. Yeah, easy for you to relate, to make too easy for you to understand. Tenaga keupayaan, potential is keupayaan, and kinetic energy is tenaga kinetic. In VM also we say kinetic. Kinetic refer to movement of any object. So the movement of any object will require kinetic energy. So kinetic energy will related to the movement of an object. So now we will look into the overall of this type of energy. Yeah. Okay, the first one, potential energy. Yeah. So you must remember potential energy. So energy is the ability to do work. Yeah. So work is done, we will use energy. Yeah. In order for work to be done, we require energy. So potential energy in this subtopic, potential energy, we will learn two types in potential energy. Yeah. Okay, the first one is gravitational potential energy. Yeah, we have two types of potential energy. The first one that we will learn is gravitational potential energy, and the second one is elastic potential energy. Yeah, potential. Okay, so and the third type of energy after potential energy, we will learn about kinetic energy. So now we will look. We want to understand. Yeah, what is the potential energy? Yeah, so potential energy. What is the meaning of potential energy? Potential energy is energy, okay, possesses, yeah, possesses by an object at certain position, okay, at certain position, okay. So potential energy is energy owned by that object, okay. So potential energy is one type of energy in which owned by an object at certain position. Okay, so what position? Okay, now we look. For example, given in your textbook, for example, when this machine, so this machine, hammer machine, okay, so when this hammer machine lifted to a height, from the bottom, yeah, from the bottom exactly before this machine function, so the hammer will be lifted up to the height. So when the hammer is lifted up at certain height, so for this given example, so at this position from the bottom, from the bottom, so here from the soil, and then this is the height, so certain height. So when this hammer is stay here, so at this position, this hammer will own what we call as a potential energy. So when this hammer is lifted up to the certain height, and it will possess an energy. It will possess or own energy. And that type of energy is, we call it as a potential energy. Yeah? So that is the simple explanation, an example to explain about the potential energy. Yeah? For example, the simple examples that always being used, so for example, we have, okay, this one. Okay, so this is the place, yeah. For example, maybe this is what we call as maybe a hill, hill. Okay, so we have person here, a boy. Okay, so when this boy walk through this hill, and then it will be at this position. So after that, okay, so when this boy walk through this hill and then be at the highest position of this hill, so at this position, yeah, at this position, this boy will have potential energy. Yeah, so we'll have potential energy. So when this boy, okay, run through this hill to the bottom, so the potential energy will be converted to the kinetic energy. Yeah, so kinetic energy is a energy that is being used for this boy to move. Yeah, so before this boy move at the top of the hill, so this boy will own potential energy. So when the boy move to the bottom, so this potential energy will change into kinetic energy. So this is the simple explanation about the definition of potential energy. So this potential energy is energy that owned by an object at certain position. Yeah? Okay. So that is a potential energy. Now we will look into the first type of potential energy. That is gravitational potential energy. So gravitational potential energy will relate to the situation like this hammer. Yeah? Okay, so when this hammer is lifted up to the certain height, so what will happen is this hammer will have gravitational potential energy. So when this hammer is released, so it will push the pile here. Yeah. So in this construction, we'll push the pile here. So the gravitational potential energy will be changed into a different type of energy in which that energy will push the pile into the soil. Yeah. So exactly this is the what we call in the 7.3 subtopic the conservation of energy, in which energy will be converted from one type to another type of energy. Yeah. So now gravitational potential energy owned by this hammer can be calculated using this formula. Yeah. mgh. Yeah. So gravitational potential energy, GPE. Okay, gravitational potential energy can be calculated by using this formula. M times G times H. Okay, so what is M? M is mass of an object. G is gravitational acceleration. Yeah. Acceleration. Okay, so gravitational acceleration is exactly the gravitational force. Yeah, is caused by the gravitational force. Yeah. Okay, and this gravitational acceleration in unit of meter per second. Yeah? And h is height. Yeah? In meter. So if you can see from this formula, yeah, from this formula, m, mass of an object, times g, gravitational acceleration, yeah, caused by the force of gravitational force of Earth, exactly is the weight of an object. As we have learned in 7.1 about work, yeah, so we have learned about work, yeah, work that equal to force time displacement, that is has S. So we have learned that force, the value of force, where we want to take the value of force. So force is exactly the weight of an object. Yeah, so when that object move, so we times S, yeah, the distance, yeah, the distance. So this weight of an object is same with this one. Yeah, so that is the relationship of between work and also gravitational force, gravitational potential energy. So based on this formula, m, that is mass of an object, times gravitational acceleration, is exactly weight of that object. Yeah. So if we want to calculate, yeah, what is the potential, what is the gravitational potential energy owned by the hammer, by this hammer, so we have to know the weight of this hammer, and then we times height. Okay, so this height exactly same with the distance that taken place when an object move, to calculate work. So exactly when we want to find the value of gravitational potential energy, so this value exactly is same, yeah, GPE is same with work done. So that's why previously I have told you that in order for work to function, so this work, yeah, exactly the value of work is same with the energy that is being used. So in this concept, gravitational force, gravitational potential energy have same value with the work done by the hammer. So when this hammer is released to push the pile, so the value of the work done is same with the value of gravitational potential energy. Okay, so this is how to understand the concept of gravitational potential energy that is same with the work done by that hammer. So when the hammer is released, so work is done, and the value of work done by the hammer is same with the value of gravitational potential energy. Okay, so that is the first thing that you must understand about the concept of gravitational potential energy. So we will look into the this one. So I have explained about this one, just now. The relationship between work and gravitational potential energy. Yeah. So this is the explanation given, in your textbook. So what you have to know that gravitational potential energy is equal to work done. So simple explanation through this diagram, figure 7.8. So if we have object here, yeah, and then when we lift okay, lift up this object to the certain height. Yeah, this is certain height. And we put this object at certain position. Yeah. So we lift up and then stay at certain position. So at this position, yeah, at this position, this object will own gravitational potential energy. Gravitational potential energy. Yeah. So how to calculate the value of this gravitational potential energy? So this object will have weight. Yeah. So weight times with the height. So we will get gravitational potential energy. Yeah. So weight is exactly mass times gravitational acceleration times height. Yeah. So mgh. So mgh will equal to the gravitational potential energy. So if we want to calculate what is the value of gravitational potential energy owned by this object at certain position, so we have to use this formula mgh, or weight times height. Yeah. So we have to find the weight. Yeah. Weight is the mass times gravitational acceleration. Yeah. And then times height. Yeah. So that is the GPE, yeah, gravitational potential energy. So when we release this object, so it will fall down. Yeah. So this potential energy will be converted into kinetic energy. Yeah, because when any object want to move, so it required kinetic energy. So from where the kinetic energy we have to take? So that kinetic energy exactly is a conversion of gravitational potential energy. Yeah, so gravitational potential energy will be converted to kinetic energy for that object, in order for that object to move. Yeah. To the bottom. Yeah. Okay. So that is the situation. Yeah. Okay. Now we look into the second type of. Oh, we have a example calculation here. So same thing. So I hope that you can read example of numerical problem for gravitational force potential energy. Yeah. Okay. So example given here shows a lift at KLCC Mall. The lift can carry a load of mass 1,500 kilogram. Yeah? So you must remember, mass unit is kilogram. Okay, mass is, the unit of mass is kilogram. So the mass of this leaf, okay, mass of leaf is 1,500 kilogram. So this is mass. Yeah. So from mass, we want to know the weight of this leaf. So what is the weight? Apakah berat leaf ni? Yeah. So from mass, so mass will times G, yeah, gravitational force, yeah, or gravitational acceleration. So we can find weight of leaf is 1,500 kilogram times 10 meter per second square. Yes, because the value of gravitational force of attraction or gravitational acceleration is 10 meter per second square. Yeah. Okay, so when we times these two value, so we will get the weight of this leaf. Yeah. So we will get 15,000. Yeah. Okay, so the unit is kilogram meter per second square. So this kilogram meter per second square is exactly a Newton. Yeah, Newton. So weight, the unit is in Newton. Yeah, so now we have weight of this leaf is 15,000 Newton. Yeah, 15,000 Newton. Okay, Newton. Okay, 15,000 Newton. So when we get weight of this leaf, so we can answer the question asked here. So the first one, how much work is done by this leaf? Okay, to a height of 30 meter. Okay. How much work is done? So work is equal to force times displacement. So as we know that force is based on weight of object. So what is the weight of the object is 15,000 Newton times displacement. So the displacement here is 30 meter. So 30 meter. Yeah. So we get the answer given here is 450,000. Yeah. Newton meter, Newton meter or joule. Yeah. So we can use either one. Okay. So now next question is, what is the gravitational potential energy of this leaf at height of 30 meter? So you can see from here, so when this leaf move from the bottom to the height of 30, 30 meter until here, so when the leaf move from the bottom to the height of 30 meter, and then this leaf will stay here. Okay, this leaf stay here. So at this position, the potential energy, the potential energy or gravitational potential energy owned by this leaf is, so we have to calculate what is the potential energy owned by this leaf. So this question, what is the potential energy of this leaf at a height of 30 meter? So we have to use the formula GPE equal to mgh or equal to weight time height. Okay, so now what is the weight? 15,000 Newton time height is 30 meter. So we will get 450,000 joule. Okay, so now work done by the leaf is 450,000 joule, and the potential energy owned by the leaf at height of 30 meter is also 450,000 joule. So from this calculation, we know that the gravitational potential energy, the value is same with the value of work done by the leaf when it moves. So then the concept here is we can say that the relationship between work done by the leaf and the gravitational force of energy is same. So the answer for C is work done by leaf is equal to gravitational potential energy of the leaf. And then the question D here, what is the power of the leaf? If the time taken to lift a load of mass 1,500 kilogram to a height of 30 meter is 0.5 minutes. So in order for us to find the power, so you have to remember the formula. So power is equal to work divided by time taken. Okay, so we know that the work done is 450,000 divided by the time. We change it to the second, 30 seconds. So we will get the answer given here is 15,000 watt. The answer is 15,000 watt, or we can change it to the 15 kilowatt. So that is the way on how to calculate the gravitational potential energy and its relationship with work done by an object. Okay. So I hope that you can little bit can understand how to calculate the potential energy. Okay, next is second type of potential energy, that is the elastic. Elastic. So this potential energy or elastic and potential energy is exactly owned by a spring. A spring. So when a spring is stretched, so when spring is stretched, maksudnya apabila spring itu ditekan, so that spring will have what we call as the elastic potential energy. So when spring that is stretched, so it will have elastic potential energy. Will have elastic potential energy. So how to calculate this potential energy? So the formula given to make you easy to understand, okay, on how to calculate the elastic potential energy is using this formula. So what is the meaning of this formula? Half times F, that is force, and X. X is the displacement. So now we have force here. F is the stretching or compression force in Newton. Okay, times X. Okay. A spring that is compressed or stretched possesses elastic potential energy. So when this elastic potential energy is released, when the spring is released, so this potential energy will be converted into work done. So the work done by the spring is exactly same as the potential energy owned by the spring before it is being released. So how to calculate the elastic potential energy is by using this formula. Half times force times X. So what is the force? Okay, what is the force? So this one, same thing, relationship between work and elastic potential energy. So when we do this activity, so we have to know the data given. So from the data, we can calculate the elastic potential energy based on the area under the graph. Area under the graph. So the area under the graph, exactly this is a very complex. So for example, given here, original length of spring. So before we stretch this spring, okay, so the force here is 0 Newton. Okay, so when we do something to this spring, so at a certain extension, so we will require certain force, Newton. So this force we converted into the graph, in which this graph xy axis is force and x axis is the extension. So when we get this graph, so the area under this graph, area under this graph will equal to the elastic potential energy. Elastic potential energy. So we require an experiment for this elastic potential energy to be calculated. Because the force that is being used also need to be calculated before we can calculate the situation. Okay, example given here. Yes.
Excuse me? Okay. Teacher, boleh teacher scroll atas? I want to ask about the definition of elastic potential energy. I do not understand.
Okay.
This one, okay.
Okay.
Elastic potential energy is the work done to compress or stretch an elastic material over a displacement of x from the position of equilibrium. Can you explain this, teacher?
Okay. This one, the simple thing that you have to understand, I have told you, okay, I have told you when any spring, when spring, because elastic we refer to spring. So when any spring, for example, any spring, okay, like this, okay, we have spring, that original spring that is not being stretched or not being what we call, that's not being compressed, not being stretched. Okay, we do nothing to this spring. So this spring we do nothing. Okay, so now when we, for example, when we compress this spring, so it will become like this, isn't it? So this is the compressed spring. Okay. So this is a compressed spring. So this is a original spring. Original spring at a, okay, original spring. So this original spring, we do nothing to the spring, and then when we compress, means that we put a force here, so it will become like this. So now this is a compressed spring. So when this spring is being compressed, it will have potential energy. And this type of potential energy is elastic potential energy. That's why when we release this spring, it will have certain work done by this spring, and this work done is same with the value of potential energy owned by this compressed spring. So for example, just example, when we compress this spring, the potential energy owned by this compressed spring, for example, just example, yeah, 10 joule, yeah, for example. Yeah. So now, when we put another object, one object, for example, marble, yeah, marble here. So what will happen is when we release this spring, yeah, so it will push the marble to here. So in order for this marble to be removed, to be moved here, so it will require energy, yeah, and that energy come from the potential energy, elastic potential energy owned by this compressed spring. Yeah. So what is the value of the elastic potential energy? So we have to calculate the height, yeah, the height of this extension when we compress. So we must have this certain distance here, and then this one we must know what is the weight here, and then from there we can calculate and find the value of elastic potential energy. So the first thing that you must understand about this concept is elastic potential energy is energy that owned by spring when this spring is being compressed. Yeah, for when the spring is being compressed. So if the spring is not being compressed, so no potential energy. Yeah. So potential energy only exists when the spring is being compressed or being stretched. Yeah. But another example is we stretch this original spring here, so it will become longer from the original position. So this, in this situation, this spring will have elastic potential energy. And the value of this elastic potential energy, so we have to use the formula given, that is half time force time distance. Yeah, the distance x. Yeah, so the distance is exactly the extension, yeah, from the original position to the stretch position. Yeah, so this one, so how to calculate this one? Okay, maybe okay. So what to go stretch in a, from the position of equilibrium. Okay, equilibrium here means the original position of the spring itself. So means that at the early stage of the spring, we do nothing to the spring. So that is the equilibrium. Yeah. So when we stretch or when we compress the spring, so the spring will go back to the original position. So the position of equilibrium is the original position. Original position of the spring. That is the meaning of equilibrium. Equilibrium is exactly equal lah. Exactly, this one is in scientific terms, equilibrium means that the left and the right of the energy is same. That is the equilibrium. Okay, so that is the elastic potential energy. So try to make a revision again and try to uh, to understand, yeah, the concept given in this subtopic. about the potential energy. Okay, so the example given here, you can see. Okay, this one. Okay, please look into this example carefully. Page what? Page 219. Okay, the original length of spring S, the original length of spring is 20 centimeter. Original length, panjang asal, without doing anything, without compress, without stretch. So we do nothing to this spring. This is the equilibrium position of spring. Means that this spring do not have any potential energy. So you have to understand this one. When we do nothing, without any force, without stretching, without compress, at the original stage, so this spring do not have potential energy. So potential energy do not exist in this original situation. Okay, so you have to understand that one. Potential energy is 0 joule. But this spring will have another type. We have other type of energy, not potential energy. Okay. So now, when the final force, okay, now we apply a force exerted on spring S is 20 Newton. Okay. Now we have a force that the value of force is 20 Newton. Its new length become 12 centimeter. Now from 20 centimeter, when being compressed, so being compressed here using 20 Newton force, now the length of this spring become 12 centimeter. Okay, so you understand this one, So you understand the situation right now. Okay, calculate the elastic potential energy. Okay, now we want to calculate the elastic potential energy owned by this compressed spring. So now we want to know what is the elastic potential energy. So you have to understand, before this spring is being compressed, the potential energy or elastic potential energy is 0. No elastic potential energy. When force is applied, when the spring is compressed with certain force, now this spring will have potential energy. So that is the first thing that you must know. When force is applied to this spring, now this spring will have elastic potential energy. The second thing is we have to calculate. Calculate what is the value of the elastic potential energy. So how to calculate the potential energy or elastic potential energy? So you can look into this solution. Okay, so the distance of compression from here, 20. So minus 12, so we will get 8 centimeter. So now the X here is equal to 8 centimeter. Because from the original length, 20 centimeter, now the spring is being compressed, become 12 centimeter. So the compression, the distance of compression here is 8 centimeter. Okay. Okay, we change it into meter. So now become 0.08 meter. Okay. So now we know the distance of extension or the distance of compression. So to calculate elastic potential energy, use this formula. So half time force. So force is given here, 20 Newton, and then times the distance of compression is 0.08 meter. So make sure you turn from centimeter to meter unit, and then you will get 0.8 joule. So the elastic potential energy owned by this compressed spring is 0.8 joule. So this is how to, the method used to calculate the elastic potential energy. So at this point, I hope that you can little bit understand. Can get a overall picture about the gravitational potential energy and elastic potential energy. So gravitational potential energy, how to calculate this potential energy is mg h. Mg is weight, h is height. For elastic potential energy, equal to half times force time distance. Distance of compression or distance of extension. So please remember these two formula to calculate the different type of potential energy. Okay, so the last energy is kinetic energy. Okay, so kinetic energy. Kinetic energy is the energy owned by a moving object. Okay, so kinetic energy, I have told you before, kinetic energy is energy used for the object to move. In order for any object to move, it will require kinetic energy. From where this energy is coming from? From where this object can move? From where the object get this kinetic energy? Exactly, the kinetic energy is coming from the potential energy owned by the object. So what happened is potential energy will be converted or changed to kinetic energy in order for the object to move. So this is the situation. Potential energy will be changed to kinetic energy when that object want to move. So the moving of this object get their kinetic energy from the potential energy. So exactly that is the definition for the kinetic energy. And how to calculate the kinetic energy? So this is the formula given here. Half times m times v square. So m is mass, v is velocity in meter per second. So in order to find the kinetic energy, so you have to use this formula. So from here exactly, the value of potential energy changed to the kinetic energy is same. So kinetic energy will come from the potential energy. When all the potential energy is being used, so the kinetic energy will also finish. So when the potential energy owned by that object finish, means that the kinetic energy of that object also will finish and the object will stop to move. So The concept here is potential energy is same with the kinetic energy. The value of potential energy is same with the value of kinetic energy. So, example given here, example 1, when a train of mass 500,000 kilogram move with a velocity of 360 kilometer per hour, how much kinetic energy? Okay, so this one, how to calculate the kinetic energy. Yeah, so use the formula given there. Yeah, so half time mass times velocity square. Okay, this one. So we will get this kinetic energy. Use this formula. Okay, so the kinetic energy, what you will learn only how to calculate the kinetic energy. And the concept behind that is this kinetic energy exactly get from the potential energy of that static, static object. So, for example, that we have learned before, before we finish. Okay, this example given here, So when object from the floor, So at this situation, at the floor, the potential energy is zero. When this potential energy is lifted up to this position at a certain height, so now the potential energy, this object will have potential energy, gravitational potential energy. So when this object is being released, it will going down, and this gravitational potential energy will be converted into kinetic energy. So during the movement from this position, at the upper position to the lower position here, so it will move. So during the move, it required kinetic energy. So this kinetic energy come from the gravitational potential energy. So gravitational potential energy will be converted into kinetic energy until it finish move to the bottom. So that is the relationship between the potential energy at certain position and kinetic energy of moving object. So I hope that you can make another revision, try to understand the potential energy and also kinetic energy, because these two types of energy relate to each other, and how to understand the situation is exactly in the 7.3. In 7.3, principle of conservation of energy will explain to you why potential energy is converted to another type of energy, for example, kinetic energy, and also other type of energy, because there are a principle of conservation of energy. So we will learn about this one next week, 7.3, principle of conservation energy. So for today, we stop our class until 7.2, and I hope that you can do the exercise given 7.2, formative practice 7.2. Try to answer that question. All of them, calculate the question given. So the attendance 26. 24. So on the 24, you remember this one. Alia, Amira, Atika, Azharin, Dahil, Hari, Matis, Mama, Ada, Afri, Azir, Mirza, Zarfan, or no, Alia, Alia Safia, Nurin Liana, Putri Dayan, Putri Anis, Indonesia, okay, so that's all for today. Please write your name in the group. Only 24 of you for this morning class. So thank you very much. You can left for me lah. Okay. So thank you very much for today attendance.
Thank you, teacher.
Okay.
Thank you, teacher.
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 Stop recording.